All right, Newton's third law of motion. This is all about action-reaction forces. So let's go ahead and get started. This Newton's third law of motion states that every action force has an equal and opposite reaction force. These forces always come in pairs. There's always two. If there's an action force, there's always a reaction force. And they always occur between two objects. So if there's not two objects, it's not a Newton's third law example. All right, so let's look at this one. So according to Newton, whenever objects A and B, so A is going to be the person, the girl, and B, which is going to be the chair, interact with each other, they exert forces upon each other. Right, we've already talked about that. Forces only exist whenever two objects are interacting with each other. You have a girl sitting on a chair. That's an interaction, so there are forces being applied here. All right, so when you sit in your chair, A, so as you can see, the girl A has a downward force that is exerted on the chair. That's going to be the action force. The action force is her weight pressing downward on the chair. All right, and then if you look at the force of the chair, B, there is an upward force that's being exerted from the chair to your body. So notice there are two objects involved, A being the girl, B being the chair. There are action and reaction forces. The action force is the girl pressing downward on the chair. The reaction force is the chair pressing upward on the girl. Thankfully, because otherwise the girl would be on the floor. So notice also the arrows. The arrows represent the magnitude of the force. So they're pretty close in size. They're supposed to be perfectly identical, but I'm not perfect. So our forces are equal and opposite. So they're equal in length, meaning magnitude, maybe 10 newtons down, 10 newtons up. And notice how I said down and up. The girl is sitting and pressing down on the chair is pressing up on her. Those are opposite forces. So this is an example of an action-reaction force. All right, let's look at a couple more examples. So in our top example, you have a finger that is being pushed on a wall. So you're pressing on a wall. So the action force would be the finger pushing on the wall. The reaction force is the wall applying a force to the finger. So there are two objects. There is an action and reaction. The action is the finger pushing on the wall. The reaction is the wall pressing back on the finger. So notice, action-reaction doesn't necessarily mean that something is moving. It just means that there are two forces, a pair of forces, that are acting on two objects, and they're being applied oppositely. So the finger's pressing on the wall is pressing on the finger. All right, let's look at the second example. We have a rocket. So the rocket pushes gases outward. So here's our exhaust flow, and it's being pushed backward or to the right. And then that helps the engine be pushed forward. So we have equal forces, one going to the right, one going to the left, and they are opposite, right, left. So the rocket pushes on the gases and the gases push on the rocket, and in this scenario, the rocket probably does move. But this is an example of an action-reaction pair. So the action is the rocket pushing on the gases. The reaction is the gases pushing the rocket forward. In our third example, we have a horse that is exerting a force on the cart. So the horse is exerting a force on the cart. So a leftward force, essentially. And then the cart is then exerting a force on the horse, going towards the right, back towards the horse. So that is also action-reaction. The horse could just be standing there, and this example would still be true action-reaction forces. So again, it doesn't always mean that the object is moving. Action-reaction is between two objects, and with these two objects, the forces are being applied to each other, equal and oppositely. So the horse is applying a force on the cart is then applying a force onto the horse. All right, thanks for watching. If you have any questions, leave a comment.